Hey, it's Mr. E here, and our aim for this video is what is the fundamental principle of counting and how do we use it to find possible outcomes? So here's your warm-up. You wake up in the mood to wear a jersey and a pair of windbreakers. From the selection shown below, how many different outfits do you have to choose from? So of course, you got your Tebow jersey in the wardrobe and your Brady jersey, and you got your three pairs of windbreakers. How many different outfits can you make with these? Think about it for a second. Okay, so with the Tebow jersey, you could wear your black, red, or blue windbreakers, and with your Brady jersey, you could do the same thing. You could wear your black, red, or blue windbreakers. How many total outfits is that? That's a total of 6 outfits. 3 outfits with the Tebow jersey, 3 outfits with the Brady jersey. So is there a principle that we can derive from this? There is. It's called the fundamental counting principle. And it says, if one event can occur in m ways and another event in n ways, then the number of ways that both events can occur is m times n. So let's take that back to our previous example. How many different jerseys do you have available? You have 2 jerseys available. So let me just write jerseys under here. And how many windbreakers do you have available? That says windbreakers, excuse my sloppy handwriting. So if you go back to the fundamental principle of counting, it says to take m and to multiply it by n. So what's our n? How many different options do we have available for windbreakers? We got 3. So it says to just multiply these and we get our total, and that's 6, which is what we got from before. Okay, that's the fundamental counting principle. If one event can occur m ways, another n ways, then the number of ways that both events occur is m times n. The nice thing about this principle is that you can also apply it to 3 or more events. So it doesn't just work for when you have 2 events, it also works for 3 or more. So let's go ahead and use that for example 1 here. Jose is considering what sandwich to buy for lunch. He has a choice of 2 different types of bread, 3 different types of cheese, 4 different types of meat. How many different sandwiches can he choose? So I just drew 3 slots here. First one's for my bread, second one is for my cheese, third one's for my meat. So I could just fill in the amount of options I have for each one. So how many choices of bread do I have? I have 2 choices of bread. How many choices of cheese? I have 3 choices of cheese and 4 choices of meat. Fundamental counting principle just says to multiply these and I get my answer. 2 times 3 is 6, 6 times 4 is 24. So there are 24 different sandwiches that he can make. When you're working with the fundamental counting principle, it's always a good thing to ask yourself this question. How many options are available in the first slot? In this case, it was 2 options because you have 2 types of bread. See that? How many options are available in the second slot? In this case, it was 3 options because you got 3 types of cheese available, etc., etc. So for the third slot, we have 4 options. Example 2. The standard configuration for a New York license plate is 3 digits followed by 3 letters. How many different license plates are possible if digits and letters can be repeated? So remember what I said earlier, it's always a good thing to ask yourself this question. How many options are available in the first slot, second slot, etc.? Okay, so let me explain why I got 6 slots. I got 3 slots here for my digits because it says that the way the license plate is set up, is that you have a digit. Obviously, it's going to be a single digit, and a digit. And then you have that followed by a letter, and a letter. So that's why I got 6 slots set up. Okay, so ask yourself, how many options are available in the first slot? Well, it has to be a digit, a single digit. How many single digits are available? Well, it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a total of 10 digits. If you don't believe me, count them again. In the second slot, well, since the digits could be repeated, I could have 10 digits again to choose from. And then in the third slot, I also have 10 digits to choose from because they are allowed to repeat. How many letters do I have to choose from? 26, right? Last time I checked, there's 26 letters in the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Yep, it's 26. So you got 26 letters available here to choose from, here and here. So to get our total, we're just going to go ahead and multiply these. So that's going to be 10 to the third. That's 1,000 multiplied by 26 to the third. And that I cannot do in my head. So let's go ahead and ask the calculator to do it. So it's going to be 10 to the third. Multiply that by 26 to the third. And that is a very large number. That is 17,576,000 license plates. Woo, that's a lot of license plates, but it is a big city. All right, so example 3. How many different 5-letter arrangements can you make out of the word maths? Again, I got 5 slots because I'm going to make 5-letter arrangements. Ask yourself, how many options are available in the first slot, second slot, etc.? Well, initially, I'm going to have 5 letters available. After I choose one letter, I'm going to have 4 letters available. The letters cannot repeat. Assume that the letters cannot repeat. Let me just write that there. So the letters cannot repeat for this example. So in my first slot, I got 5 letters to choose from. So once I pick one letter, I'm going to have 4 letters left. Once I pick 2 letters, I'm going to have 3 letters left. Then 2, then 1. You get the point. So it's going to be 5 times 4 times 3 times 2 times 1. That's also known as 5 factorial. Let's type in 5 factorial in the calculator. So you press 5, go to math, go to probability, go down to 4, and that's your factorial symbol. 5 factorial is 120. So the answer is 120. Example 4. Okay, so you see that we're going to ignore this thing here for now. We're going to come back to that in a second. It says, whoops, excuse me. All right, example 4. How many different 3-letter arrangements can you make out of the word wow? If you use the same approach as before, you're going to run into some trouble, and I'll explain to you why in a second. So you might be tempted to say the answer is 3 factorial because you have 3 letters to choose from, and then 2 letters to choose from, and then 1 letter to choose from. And you're going to be tempted to say that the answer is 6. But the answer is not 6, and I'm going to tell you why. If you actually list the arrangements, these are the arrangements. What do you notice? These arrangements are just a repetition of the first 3 arrangements. And it says How many different three-letter arrangements can you make out of the word wow? Question mark there. So it's actually only three different arrangements that you can make. So that's where if you're going to do it the way we've done the other examples, it's going to fail you here. So there's got to be a way around that, and there is. And that's what I had earlier here. To get rid of the repetition, you have to divide by the frequency of each letter that repeats factorial. So what do I mean? Look at the letter W. The letter W repeats, and it repeats twice. So if you want to get rid of the repetition, you're going to divide by 2 factorial. So that's going to be 6 divided by 2, you get 3. So the answer is 3. There are 3 different 3-letter arrangements that you can make out of the word wow. And by the way, they're listed here. Okay, I want you to try this example. How many different 6-letter arrangements can be made using the letters of the word tattoo? There is repetition here, so be aware of that. If you want a hint, you could keep playing the video. If you want to do it yourself, you could stop it now. Okay, so since the letter T repeats 3 times, I know I'm going to divide by 3 factorial. And since the letter O repeats twice, I'm going to divide by 2 factorial as well. And then I'll let you figure out what the numerator has to be. I hope this video helps. Take care.